Hi, we are Team 7. My name is Jayant Reddy and we have Meng and Nitya in our team. Today we are going to discuss about programming language named Sha. The code structure is adapted from Java and the simplicity is taken from Python. That is no semicolons and no main function requirements. And speaking of compiler for this language, it is written in Java and runtime is written in Python. And the main reason why we named this programming language Sha is it acts as a shadow for both of these major languages, Java and Python. And the file name is written with .sha extension. Speaking of features for this language has incorporated three data types, that is int, boolean and string, and we have two control structures, if, else and while loop. And this language takes a function with 0 or more arguments, and this language provides a return, and also we have recursion. And speaking of why SHA unique is, this is a language for programmers, just like COBOL that is used for business operations. This language runtime is designed in such a way that it provides each and every step of how it is implementing to generate a particular result. We will be having a good discussion on this while we have demo. The grammar for this language has this structure where expression can have multiple inputs and all. The whole language is written in block structure, and we can have a while, if and return expression. Everything is written in block, and we have designed a proper semantic structure for this in order to perform certain operations. The lexical analyzer Antler is used to generate to perform this lexical analysis. Antler is actually implemented in Java, and this is the structure of how a grammar should be written for Antler. Identifiers are written with the similar structure that we have mentioned here. Integer can take single or multiple digits, and we have comparison operators which has multiple equal to, not equal to and all. These are the basic structures, and this grammar accepts brackets and parentheses. In order to skip any character like white spaces, tabs and all, we use this white space character which is provided in Antler itself. Parsing. Lexing and parsing is provided by Antler, so it becomes quite easy while performing certain operations. This reads token from the scanner and looks for phrases in the grammar in a top-down fashion in order to perform these operations. And compiler. The compiler is built on top of this recursive descendant parser. When a compiler traverses each node in the parse tree, a certain operation is assigned to the node. It is written by our programmers in order to generate a certain intermediate code which will be appended on the list, and the data is sent to .txt files for a runtime environment. This is how the structure of code from source code to intermediate. First of all, a programmer writes his code in SHA, and it is checked with grammar and evaluated with parse trees. If the tree is correct, then a proper output will be generated. If it is wrong, an error at the tree will be displayed with a different color. And the Antler grammar has .g4 extensions. And the intermediate code is sent to .txt file, which will be read by our runtime environment. And the runtime. This is the special part of our programming language. It is written in Python. In order to make it simpler, we have implemented stack and three registers. One of the register makes an input from functions, and the intermediate code which is generated from .txt files is taken as an array of lines and it is passed accordingly. We have has attribute and get attribute to check all the function calls, and a separate block is maintained to identify each and every individual blocks that we write in our program. This is the structure of from intermediate code to output. Intermediate code will be directly provided to runtime environment, and from there to output. This is simple, and much more will be explained while we have demo. And let's get SHA into act. Let's look at the demo of our SHA. The following is a grammar which is used to write SHA. The whole program will start with this kind of blocks, and then it will go into block statements which has flower brackets, and then function declaration, local variable declaration. Everything will be declared accordingly. And let me give you a short demo of our project with some simple declaration and then if and else statements. Since the program should start with open and close blocks, I have given blocks, and these are the open and close flower brackets. I'm declaring int a is equal to 10. This is a simple declaration statement for int. If a equal to 10, I'm declaring another variable for this if and else statements. Int b is equal to 20, else b equal to 100. This is a simple if and else statement with some declaration. I'm gonna save this file. Now I'm gonna run this file using Antler. Now I have compiled it, and now I have ran this file. Yes, so some other classes will be generated by this Antler tool, which will be explained later. Now I'm going to generate parse trees, testing whether this code is compatible with this grammar or not. This is the parse tree for this grammar, which has start block, and then evaluated open and close blocks, and open and close parentheses, and some declaration. If we have any error in this tree, then it will be displayed with some different color. Now our tree is completely fine. Now let me explain. When I run that program, some of the classes will be generated, which are base visitor class, lexer class, parser, tokens, and lexer token classes. As a part of our convenience, I have used base visitor class and have overridden each and every functionality. Now you see the functionality here, and each and every functionality is a non-terminal node of our grammar. Now you need to override these non-terminal nodes in order to evaluate how to evaluate your parse tree. So in order to override each and every functionality, I have used my visitor class to override these functionalities. And this my visitor class contain each and every functionality which needs to override our parse tree. mm, for example, for this if and else statement, let's have a look at this block. When I reach if, I will reach out to this parse tree and then get the child statement. I perform this operation sr1 dot push, and in order, this is how our intermediate code looks like: sr1 push, check, s block, else, check, and block. And similarly, we have evaluated the same and produced intermediate code for recursion, functions, while statements, and all. So and this is the main. Actually, I have generated a list which saves each and every value, and it is produced to main, and the main stores this data in a file, so that this file will be passed and taken as a feeding input to our runtime. Now I'm going to run this file. No errors. And this is how an intermediate code will be generated for this. As I've used three registers and one stack, it will be pushed and evaluated accordingly. And for if and else statement, we have start block, end block, start block, and end block for if and else. So let me get into runtime. Here is the runtime for our program. I'm feeding this value as an input, the text file as an input here. The runtime has a special feature which shows how a program is running. So let me run this. No errors. So I did not produce any output statement for this, so no output, just without errors. Now if you want to see how this runtime is working with these registers and stack, you can initiate this variable and you can see how it is performing these operations. Here false indicates that no functions are declared in this program, and we have stacks and registers evaluating the functionalities and their operations. Since this r1 and r2 values are equal to the stack values, it did not produce any error. Next we will explain about function declaration and while operation with factorial operation. Here we are giving 10 as an input, and so it should perform the factorial operation. Here, this is how the code is written in Shell. Now I'm going to copy the code and paste it in our new folder. I'm going to run this project. So this is how the tree is generated. This class, main class, and no errors. So intermediate code, this is how it is updated. Now since I've named the function as factorial, I can see fact here, and a start block and end block, jump statements to evaluate while operation, and the input 10 is given here. So this is fed as an input to our runtime environment. So each and every operation is presented here with multiple registers and a stack, and the output is presented here. If you don't want to see all these operations, if you directly want to see an output, we could change the label to false, and we can directly get to the output. So similarly, we can perform the same operation for recursion as well. So here is our recursion code to evaluate the same factorial operation. I'm gonna copy this code and present it to our tester SHA file, and I'm running this code, and again we don't have any errors, so no errors. And now this is fed as an input to Python file, so let me run it. So again the same output. So this is how program supports recursion, and we have presented each and every operation as a SHA manual in our documentation. This is our it contains each and every operation that we have performed, and line to line explanation for new users. Compiler, how a compiler generates multiple classes, and how a runtime performs its operation, how intermediate codes are generated and their opcodes as well, and type systems with some examples of grammar and trees and their examples. and our references to this project, a complete project. Thank you.